All right, this lesson is on polynomials in factored form. All right, so we just learned about standard form a little bit. Factored form is going to be more helpful for us here in Algebra 2 because it's going to help us identify our x-intercepts, just like factored form of quadratics did. All right, remember, quadratics is just a polynomial of degree 2, so a lot of the same stuff is going to play the role here, except there's just going to be more factors. All right, so here's factored form. We got A, we got the leading coefficient. All right, and then all these factors, x minus z, I use z for 0, the x-intercept, they're going to be related there. All right, how many factors are there going to be? The factors should match up, okay, with the degree. The most factors will match up with the degree because, again, the degree will match up with the number of x-intercepts, and factors relate back to the x-intercepts. All right, so if z was 10, right, we'd have 1 factor, 2 factors, 3 factors, 4 factors, all the way up to 10 factors, okay? And these are all going to relate back to the x-intercepts. So from factor form, we can identify n behaviors, just like standard form. X-intercepts, okay, what makes each factor 0? The multiplicities of 0, something that we have not looked into in the other polynomials. But what if a factor is repeated more than once? What's that going to do to the zeros or the x-intercepts? The maximum number of relative extrema. So n behaviors and their extrema all depend on the leading coefficient and the degrees. So I still have a leading coefficient, okay, and I still have a degree. All right, just a side note on the leading coefficient. Sometimes the factors will have a coefficient in front of the x. If it does, that is part of the leading coefficient. All right, I could take it out and multiply it to whatever number is there, and it's just going to change my z as to a rational number in fraction form. For now, we won't worry about that. So how do I identify the degree? Okay, it's very simple. Okay, to identify the degree of polynomial factored form, you can either multiply it out and put it in standard form, which is not that simple, especially if there's a lot of factors. Or here's a simple technique. You just add up the exponent of each factor. All right, so some factors may have an exponent out there. You just add up. So if there was 10 factors, right, all have an exponent of 1, have a degree of 10. All right, so I got some examples of that right here. So right here, this one has 4 factors. Every exponent is 1. The exponents on the x are 1. The exponents outside. So this is just a degree of 4. Okay, now this x plus 2 squared means that factor is there twice. So that has a degree of 2, this one a 1, this one a 3, this one a 1. So you add all those up. 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 1 is 7. This would have a 7th degree polynomial. Again, that's odd, and behavior is going in opposite direction, leading coefficient is positive, so the right end behavior is positive. All right, here we got this x out in front. Is that a factor? That is. Remember, it's just like x minus 0. So that's 1, 1, 2, 1, 1. Add all that up. 2, 4, 5, 6. This would have a degree of 6. Even, leading coefficient is positive, so both end behaviors are positive. Okay, maximum number of x-intercepts is 6, so forth. So here we got, okay, we got a 1, got a 3. Now there's a 2 inside here. All right, so that again, it's going to be the degree of that exponent, okay, on that factor is 2. Now, even if there was an exponent out here, I'd have to multiply them together. All right, but this is 2, plus 3 is 5, plus 1 is 6. This is also a degree of 6. Remember, you could write x squared minus 1 as x plus 1, x minus 1. That's 2 different factors right there. So again, how do I find the degree in factored form? You just add up the exponents of each factor. Sometimes the exponents can be on the outside of the parentheses, sometimes they're on the inside, sometimes they're both, okay? But you just have to add up all the exponents. All right, so let's take a look at some graphs of polynomials graphed from factored form and see what we notice. All right, so here we have negative, okay, times x minus 1, x plus 2, x minus 3. What's the degree? There's 3 factors there, all with an exponent of 1, so the degree is 3. The leading coefficient is negative. Okay, what are the values that make each factor 0? So what makes this one 0? Right, x equals 1, negative 2, and 3. So those are the values that make each factor equal to 0. Okay, what do I notice about my end behaviors? All right, well, my end behavior should be opposite direction because my degree is odd. My leading coefficient's negative, so my right end behavior should be going down towards infinity, which it is. Okay, so as x approaches positive infinity, so my right end behavior, y approaches negative infinity. My left end behavior, as x approaches negative infinity, y approaches positive infinity. All right, now noticing what are my x-intercepts. Okay, my x-intercepts are negative 2, 0, 1, 0, and 3, 0. And what do you notice the connection between those two answers? All right, and that's why factored form is a little bit more helpful than standard form because it still tells us the same thing about the end behaviors, okay, and the direction. But now, it not only tells us the number of x-intercepts, it tells us the x-intercepts, so I know exactly where they are. All right, if I wanted to find the y-intercept, okay, I would just plug 0 in to the x and then just multiply those numbers up together. All right, so here we have, okay, another one. So I'm just looking at this graph, okay, my end behaviors are both going up. My degree should be even. So let's take a look here. I got 1, 2, 3, 4. Okay, this does not have an x on it out here. This is just the leading coefficient. This is not a factor. All right, so my degree is 4. My leading coefficient is positive 1/2. All right, so end behaviors even. So the end behaviors should both go in the same direction, which they are. It's positive, so my right end behavior should be going up, and since they're the same, so should my left. All right, what values make each factor 0? So just going in order down the line, I get positive 2, negative 2, negative 3, and 1. Okay, so my end behaviors here, they're both going up. So as x approaches infinity, so the right end behavior, y approaches infinity. Left end behavior, as x approaches negative infinity, y approaches positive infinity. Okay. Both going up because the lead coefficient is positive and the degree is even. The x-intercepts, okay, so negative 3, 0, negative 2, 0, 1, 0, and 2, 0. All right, and again, those are going to match up. All right, so on this one, we got factored form, x plus 1 cubed times x plus 2 times x minus 1 squared. So I really want to pay attention to what's going on, okay, at the x-intercepts for these particular factors that are cubed and squared. All right, so what's the degree? So we add the exponents, 3, 1, 2, that's a degree of 6. That's even, which matches my end behaviors going the same direction. My leading coefficient is 1, it's positive, so both end behaviors are up. All right, so as x approaches infinity, so does y. And as x approaches negative infinity, y approaches infinity. And both are up. All right, my x-intercepts here, I have 1, 2, 3 x-intercepts. Okay, negative 2, 0, negative 1, 0, and positive 1, 0. All right. And if you see that, right, there's 3 factors there, even though that x cubed means it's actually there 3 times. Right? We only see it once because it's repeated, right? What's that do to the x-intercept at that point, right? This one squares there twice. What's that do for the x-intercept? So what is happening at 1, 0? What is happening right here? Okay, right there, okay, it's a minimum. It bounces. Okay, I like to say it bounces off the x-axis. So it hits it, doesn't go below it, and just changes direction right there. It's a relative extrema, right? So that squared, it happened twice, okay, that it's going to bounce, all right? So what is the exponent? That, remember, it's squared. So when exponent is 2, okay, it bounced off. What is happening at -1, 0? What's happening right here? Okay, well, right here, it gets really flat, but it still goes through, right? Unlike over in this -2, just goes straight through. Here, it gets really flat, okay? It changes concavity right there, right? And so we call that, okay, here's a vocabulary word for you, okay, it has a point of inflection, okay? There is a point of inflection, okay? It gets really flat. And the exponent there is 3, it's cubed. So on that odd one, okay, on the odd exponent, it gets really flat. Again, we call that a point of inflection. Right? On the even exponent, it becomes an extrema point or it bounces. All right, so some interesting things are happening if I add exponents to the factors. So if the factors are repeated an even amount of time or an odd amount of time, it affects how it hits the x-intercepts. All right. Look at one more here. We got -x squared times x plus 2 cubed times x minus 1 squared. So what's the degree here? We have the exponents 2, 5, 7. Odd. My end behavior should be going opposite directions, which they are. This one's going down. Right end behavior is going down, so my lead coefficient should be negative, which it is. It's -1. Okay. The end behaviors. Okay, what's going on for my end behaviors? So here, as x approaches infinity, my right end behavior, y is going down. Y is approaching -infinity. And my left end behavior, as x approaches -infinity, graph is going up, so y approaches +infinity. And again, that should make sense. It's opposites. Okay, what are my x-intercepts? I have 3 of them. Okay, -2, 0, 0, 0, and 1, 0. And again, those match up, okay, with what makes each of the factors equal to 0. All right, and let's take a closer look, okay, at the factors that were squared. Okay, so on the factors that were squared, again, what's it doing? It's hitting and it's bouncing. Okay, so same thing here. Okay, it causes a relative extrema. Okay, it bounces off the x-axis. And what's the exponent there? It's squared. It's 2. Both of those. An even exponent, okay, causes a bounce. Okay, we also refer to this as having a 0, an x-intercept with a multiplicity of 2, because it happens twice. It only in the graph, it's only one x-intercept. Okay, but we say it has a root or a 0 with a multiplicity of 2. All right, so describe what happens at -2, 0. Again, it gets really flat. Okay, it's really flat. We call that a point of inflection. All right, and the exponent there is 3. So we say that's cubed. Again, it's odd, and we get that point of inflection. Okay, when a polynomial is in factor form, how do you find the degree of the polynomial, right? You add up exponents on each factor, right? Or you multiply it all out, which is still good, but just takes a lot of work, especially when there's lots of factors. When a polynomial is in factored form, how do you find the x-intercepts? Okay, we find what makes each factor 0. When a factor is squared, okay, what happens at the x-intercept? Okay, it bounces off the x-axis. Right? It's an extrema point. They're a relative min or a relative max. When the factor is cubed, what happens at the x-intercepts? Right? It gets really flat. Right? We call it a point of inflection. How do you find the y-intercept when it's in factor form? Plug in 0 and evaluate. All right, and so there's some information about factored form.